this, man.
You can't rock no more.
It's been a long time coming. Really though, I ain't even frying. Fans asking me when it's dropping. I kept telling them soon. I was straight up blind. I had no clue. I gave up trying. It's been a long road running. So cold, demons and ghosts troubling my soul. It was humbling, yo, but there ain't no stopping for me. Going hard as a break, straight stomping his beat with kicks till it bleeds. I admit the defeat, but I'm back on my feet. About to work till it hurts. Put fire in every verse. Ride till my tires catch fire and burst. Rhyme till I'm tired and lying. The hearse, I'm a fire till your body's outlined in the streets. I'm a rider, still young, no retiring from me. Drop songs till you get tired of me. Seen signs, your average rapper. I live you in awe, fending for more. Search to your playlist, digging for songs by 48 beers. I know I was gone, but I'm finally here. Finally appearing on lyrics, higher than roofs, shining the chandeliers. The West African vibe is here.
I'm not a regular Joe. All these people know the old me's gone and dead like yesterday. I'm about to blow. Somebody clear the road. It's my moment, and I'm not letting go. I'm gonna rock.
So today we're hitting our changing of the subject of our equation and substitution. So let us get the whiteboard. All right. Changing the subject of our equation. So if I give you a nice simple equation, B equals U plus A times T. So this is an equation from science. So particularly from physics, it's one of your equations for motion, for linear motion. That sort of thing you don't need to worry about. Now, if I say to you, change the subject to be U, what am I actually asking you for? I'm actually asking you to get this equation to become U equals something, something, something. Well, in this scenario, that's not very difficult. I want to try and get U by itself, so I need to move this. And to get this whole thing to the other side, it's currently being added, which means when we move it to the other side, we do the inverse operation, which is subtraction. So it's V minus AT equals U. And I'm a happy man. Very easy. What about if I ask for the subject to be T? So from initially the V equals U plus AT. Well, that means I need to try and isolate this. Well, not too difficult again, but it's a little bit more. So we first got to isolate this term with the T in. So take the U over, V minus U equals A times T. And then we're going to get T by itself. So essentially, we can treat A just like a normal coefficient. So when dealing with that, I'm going to have to divide the A. So I divide this whole thing by A and that whole thing by A. Please note, I'm dividing the whole side. Not just the V, not just the U, but both of them. So they cancel over there, and then I'm left with this equation as V minus U over A equals T. And once again, I'm a happy man. Now, you might be saying to yourself, I can kind of understand what he's doing, but why? Why am I concerning myself with dealing with all of these letters, changing them around? For what purpose? Well, the purpose comes in with substitution. So, if I give you the following, V equals U plus AT, and I tell you that V is 20, A is 2, T is 5, and I need to find U. There are two ways of doing this. Either you substitute in and then solve for U, or solve for U and then substitute in. So, because I like to be complete, I'm going to show you both methods. The one of the methods you would have seen already. So if I sub in V, I get 20 equals U plus A, which is 2, and T, which is 5. So I can multiply these. So I get 20 equals U plus 10. Take the 10 over, becomes a minus. So 20 minus 10 is U. So U is just 10. Great. And that's the way that most of you will probably do it. So you would sub in the values, and then you can work with numbers far easier than you can work with letters because you're more used to it. Or you could rearrange it first. So I need to make U the subject of the equation. So I therefore have V minus AT equals U. This we've already come across from our very first example. We sub in our values, 20 minus 2 times 5 equals U. Plug that into a calculator, or work it out in your head or on paper, whatever. 2 times 5 is 10, 20 minus 10 is 10. Done. Both of them give you the exact same answer, which we're expecting because it's the same thing. So why do you have to manipulate? So changing this equation is part of a skill that we need to know, because when you get to more complicated maths, you very well possibly might have to take stuff over, refactorize, cancel, divide, do a whole range of things. And this changing the subject of the equation is how we practice manipulating equations. What about the other one that we did? So we did V equals U plus AT, and I said to you, V was 20, U was 10, our A was 2, and we have to find T. Now, from our previous question, we know that T is 5, because I'm using the exact same values. Does it matter if it's 20 equals V or V equals 20? No, not at all. So once again, I can use either method. So V is 20, U is 10, A is 2 times T. So 20 equals 10 plus 2T. Take the 10 over, we get 10 left because it's 20 minus 10 equals 2T. Divide by 2 on both sides because this is a multiplication. It cancels, and we're left with T equaling 5, which is good because we know it's meant to equal that. What about on this side? Well, on this side, we could manipulate first. So V minus U equals AT. We divide by A on both sides. They cancel. So T is V minus U over A. Sub in my values over 20 minus 10 all over 2. So 20 minus 10 is 10, over 2 is 5. So T is 5. And that is exactly what we expected, that it would get you the exact same answer. Now, you may notice that the actual calculation here is easier because you can literally just type it into a calculator and get your answer. It's one step. But then you have to work with all of these letters here beforehand. So you need to be able to work with both options because the question will depend on which option you choose. Any questions so far? Hopefully that was not too quick for you guys and you're following what I'm doing. All right, good stuff. So let me give you a bit of a tougher question. So what about if I say, so this is kinetic energy, but just so that we don't have a confusion of notation, I'm just going to put it as E. So kinetic energy equals a half mv squared. Again, another science formula for the energy of motion, your kinetic energy. I say to you, I want you to change the subject to be V. So take a little bit of time, try and work that out. All right, now that you've had some time, let's go through this. So we are trying to isolate V. We're trying to get V by itself. We are unable to have more than one V in the equation if V is the subject. So one of the options that has been given, V equals E over a half mv. This is a problem because there's a V and there's a V. This is the one we want. This is the one we want to get rid of. All right, so this is one term, so there's nothing to add or subtract to either side, which means we're now going to have to multiply or divide. So this half m is like a coefficient of v squared. So we can divide the half m to the other side. So we get E over a half m, which equals v squared. Now, if you divide by a half, that is the same as timesing by 2. And we know this because of your tip and times rule. So that's actually 2e over m, which equals v squared. Now, that change from the half to the 2, not direly critical, but it just makes it neater. The more important part is, how do I get v by itself here? Well, what's the problem? What is stopping me from having v now? Or what is stopping me is the squared. And as I've told you already, to move stuff to the other side, you've got to use the inverse operation. Or what's the inverse of squaring something? Well, it is square rooting something. So therefore, the square root and the square cancel. And you're left with the square root of 2e over m that equals v. And that is your final answer. So this was a closer option, except this v was not meant to be divided through. That v was meant to stay up here, to stay as a squared, and then you square root. Now, if I say to you, given that E is 200, M is 20, calculate V, you could again either sub it into the beginning or sub it into the formula that you have already, because we are now trying to find V. So V equals the square root of 2e over m, which is the square root of 2 times 200 over 20. Therefore, 2 can cancel with the 20 to become 10. This 10 can cancel with 1 0 there. And then you are left with the square root of 20, which on your calculator will give you 2 root 5. And that is a perfectly acceptable answer.
Example 2 says, evaluate minus 3d multiplied by 4d squared minus 3 over d cubed plus d if d is equal to negative 2. So again, let's write this out. We've got negative 3d multiplied by 4d squared minus 3 over d cubed plus d. Now remember that your variable d is simply a placeholder. So wherever you see a d, you're going to put a negative 2 and make sure that you don't forget the sign. Okay, so this is equal to minus 3. Now we've got a d and we know that d is a negative 2. Okay, so open your bracket. You've then got 4. We then have d squared, so that's minus 2 squared. It's not 2 squared. Be very aware of that. Then we have minus 3 over d cubed, so that's minus 2 cubed, plus d, so it's a plus, and then d is minus 2. Okay, so you're going to have to be very careful with your signs over here. Now again, we're not going to use calculators. Okay, so before we fiddle with the outside over here, let's work with this bracket inside. So we've got minus 3 times minus 2. Then we've got 4 multiplied by minus 2 squared. So that is actually 4 multiplied. Now remember, minus 2 squared is plus 4. So we're just going to put a 4 over here. Minus now, we've got a 3. And now you've got minus 2 cubed. Now, minus 2 cubed is equal to minus 8. Why? Well, remember that minus 2 cubed is minus 2 times minus 2 times minus 2. Okay? So that's 3 over minus 8. And then we have a plus minus 2. So a plus and a minus gives us a minus. So that's just a minus 2. Okay? So let's just now neaten this up a little bit. We've got minus 3 times minus 2. We then have 4 times 4, which is what? It's 16. Now, you can see that we have minus 3 over minus 8. So this minus over here and this minus will give us a plus. So we have plus 3 over 8. And then we have a minus 2, okay? So we've got minus 3 times minus 2. Now we've got 16 minus 2, so that's 14, and then plus 3 over 8. So at this stage, let's just leave our answer as a mixed fraction. So we have minus 3 times minus 2, and 14 and 3/8. Okay, so what's the next step? Well, we're now going to be dealing with minus 3 times minus 2. Now, minus times a minus is going to give us a plus. So we have plus 3 times 2, which is plus 6. And you're multiplying that by 14 and 3 over 8. Okay, so we're making nice progress. So what do we do at this stage? Okay, well, what we can do at this stage is say this. We've got 6 multiplied by 14 and 3 over 8. Now we're going to convert this over here to an improper fraction. So remember, to do that, what you do is you go 8 times 14 plus 3. So it's 8 times 14 plus 3 over the 8. Okay? Now 8 times 14 is what? So 8 times 10 is 80. And then plus 8 times 4, which is 32. So it's 80 plus 32. So it's 112 plus 3. And 112 plus 3 is 115 over 8. Okay? So this is the same as saying 6 multiplied by 115 over 8. Now, these cross-cancel. The 6 can cross-cancel with the 8. How, though? That's the question. Well, they don't cross-cancel perfectly. If we divide the 6 by 2, okay, we're going to be left with a 3. And then we still have our 115, but we're also dividing the 8 by 2. So we've got a 4, okay? So actually now you can go 3 times 115, which is 345 over 4. And of course you can simplify this. You can convert this back to a mixed number, but truly, if you just left it as 345 over 4, you've shown your teacher or the examiner what they want to assess. They want to see if you can substitute, and then you can actually work out what the answer will be. So if you left your answer as 345 over 4, in my opinion, you would get all of the marks, unless the instruction is to convert this to, say, a mixed number. Example 3. So we have been asked to evaluate a cubed multiplied by b minus 2a squared b to the power of 5 minus a to the power of negative 1 multiplied by b squared, all of this being cubed, plus 8, and you're told that a is minus 1 and b equals positive 1. So I can tell you immediately that when you get substitutions where you're dealing with minus 1s and plus 1s, the examiners are trying to test your ability to get all of the signs right when it comes to cubing, and then you've got your minuses and your brackets and all of these types of things. So guys, before we start, okay, let's just actually cut this page over here so we can work within a nice space. Before we start, you can see that you've got this negative exponent over here. So what I want you to do is just to neaten this expression up. So this is a cubed b minus 2a squared b to the 5 minus, in brackets, then we've got b squared over a, because remember that a to the negative 1 is equal to 1 over a plus 8. Okay, so now let's substitute. So we've got a cubed. So a is negative 1. So this is negative 1 cubed times by b, which is plus 1. Minus 2. Now a squared is minus 1 squared. B to the 5 is going to be plus 1 to the 5. Minus, now b squared is plus 1 squared, over a, which is just minus 1, plus 8. Okay. Now, minus 1 cubed is what? Well, minus 1 cubed is minus 1, and then plus 1. Then we've got minus 2. Now, minus 1 squared is plus 1, and plus 1 to the power of 5 is just plus 1. Then we have a minus. Now we've got our brackets. Plus 1 squared is what? Well, plus 1 squared is going to be plus 1 over here, minus 1. And then we've got a plus 8. Okay, so already things are looking more simple. Now, minus 1 times by plus 1 is minus 1. Then we have minus 2. Okay, so let's keep this here for now. What is plus 1 times plus 1? Well, that's plus 1. Okay. Then we've got a minus over here. Now, plus 1 divided by minus 1 is minus 1. And then we've got a plus 8. Okay, so things are looking really good now. So we have minus 1. Then minus 2 times plus 1 is minus 2. And then we have a minus minus 1, so that becomes a plus 1 and plus 8. So, minus 1 minus 2 is minus 3. Minus 3 plus 1 is minus 2, and then minus 2 plus 8 is plus 6. So your final answer when a equals negative 1 and b equals positive 1 is going to be positive 6. In this lesson, we will consider the definition of probability, the probability scale, and terminology used when discussing probability. So, let's look at the definition of probability. Probability is the likelihood of a particular event occurring. Imagine what could happen if a giant meteor collided with the Earth. Scientists may want to know how likely it is that this may happen. In this case, they will want to know what the probability is of a meteor hitting the Earth. In mathematics, we express probability using the symbol P. For example, the probability that Tuesday will have rainy weather can be expressed as. Let's now look at the probability scale. Probabilities can take any number between and including 0 and 1. So, what does the probability scale actually tell us about probability? If a probability is equal to 0, then this means that the event that we are trying to measure is impossible. For example, a lion turning into a giraffe has a probability of 0 because this event is impossible. Now, if the probability of an event equals 0,5, then the event is equally likely. This means that the event will either occur or not occur with the same probability. Now, what happens if the probability of an event equals 1? This means that the event is guaranteed to occur. For example, if you throw a rock off a building, then it will fall. This is guaranteed, and so we say that the probability of a rock falling if you throw it off a building must be equal to 1. So let's now look at the probability scale. An event with a probability between 0 and 0.5 is said to be unlikely. For example, snow in Johannesburg. An event with a probability between 0.5 and 1 is said to be more likely or highly likely. For example, a car accident on one of Johannesburg's busy highways.
Well, I went to play my